This first image of 3I Atlas comes from the Hubble Space Telescope, processed and shared by Toni Scarmato. At a glance, it looks colorful and dramatic, but this isn't about aesthetics. These are false colors, used deliberately to map brightness across the coma. Brighter regions are pushed toward green and yellow. Fainter dust fades into red and purple. What you're really seeing is structure. And that structure isn't symmetrical. The coma is clearly lopsided, with one side denser and more active than the other. That asymmetry matters, because it tells us where material is being released and how it's evolving after perihelion. Now look toward the lower left. That broad, sunward-pointing feature isn't a mistake. It isn't a stretch artifact, it isn't overprocessing. As Toni notes directly, the anti-tail is always there. That's the key phrase. Across different stretches and different presentations of the same Hubble data, this feature doesn't disappear. It persists. Which means it's not noise. It's geometry and dust dynamics doing something counterintuitive. Dust that was released earlier in the orbit can settle into the orbital plane. Under the right viewing angle, that dust lines up and appears to point back toward the sun, creating an anti-tail that looks wrong until you understand the geometry behind it. So this image already tells us two important things. First, the coma's activity is directional, not random. Second, the presence of an anti-tail here is stable behavior, not a transient glitch. And once you accept that, the next images stop looking strange and start looking structured. Because when this same Hubble data is pushed further, the coma doesn't just look asymmetric, it breaks into jets. Left panel. What you're seeing here is the same January 7th Hubble dataset, presented close to its natural structure. Nothing is being subtracted, nothing is exaggerated beyond brightness scaling. The coma looks continuous, with a smooth fall-off away from the nucleus. If you stopped here, you'd say this is a fairly ordinary active comet with some asymmetry and move on. That's exactly why this panel matters. It establishes the baseline. Right panel. Now the same data is passed through the Larson Sekanina rotational gradient filter. This method removes the smooth coma component and isolates repeating, rotation-linked features. In other words, it asks a very specific question. What parts of this coma are organized rather than diffuse? And the answer is immediate. The coma resolves into a three-jet system. Two jets fan outward, while a third, sharper feature points back toward the sun. That sunward jet is the anti-tail, and here it's unmistakable. It isn't broad, it isn't fuzzy, it's structured. The scale is what stops this from being a minor detail. The anti-tail extends to roughly the Earth-Moon distance. That puts it well beyond a local surface effect. Whatever is producing it is sustained and directional. This is the point raised by Avi Loeb. Loeb's focus isn't on speculation, it's on morphology. A sunward-pointing jet of this length is not what basic radiation pressure models predict. To explain it, you need a very specific combination of dust size, emission timing, geometry, and viewing angle, all lining up just right. Possible? Yes. Trivial? No. That's the shift. The left panel shows why this could be overlooked. The right panel shows why it shouldn't be. Same telescope, same exposure, same moment in time. Different processing reveals that the activity is not diffuse, not chaotic, and not accidental. It's organized. And that's why this image pair matters far more than either frame on its own. And this is where I want to hand it to you. If a single Hubble dataset can look this ordinary in one view and this structured in another, the real question isn't whether 3I Atlas is strange. It's how much of its behavior we're still missing because we haven't looked the right way yet. So here's the question. Is this anti-tail just an extreme case of geometry and dust physics? Or is 3I Atlas showing us a mode of activity we don't yet fully understand? If you want updates as new data drops and this picture sharpens, subscribe and stay with the series. I'll keep breaking these images down as the story evolves.